configuration and sample result. Okay, so disclaimer, yesterday I already ran the HWCCT for the REL 01. So for the result for hardware CCT long test, we will use the sample on the REL 01, right? So it takes about okay. So the same as HCMT, HANA DB installer, even the HWCCT. Once you download the software from SAP, it will be in the SAR file, okay, like this one. Okay. So what you need to do, you need to extract using the subcar, and then once we extract the, for example, /subcar minus xvf, and then HWCCT, for example, 237. Then once you execute this command, then it will create a folder like this one. This is the folder that I mentioned during the presentation. The long name in a single word, hardware configuration check tool. Okay, so if you go inside the folder, okay, you will see a few things, especially the profile, ENV profile message, all the JSON file, and etc. Okay, and then during my presentation, I said that we need to source to this ENV profile.sh because it will call a library. Okay, let's check what's inside. Okay, the compat are here. The compat SAP C++ 7.2.1. This is the library that will be called to enable the HWCCT. If let's say your Red Hat Alpha in the customer side or maybe on your environment, you don't have this library, then you can download. I already upload inside the same link that you download the slide today. There is one file called compat sub C++ as well. So you can use, I think I can show here. Okay, inside this folder, I have shared with you guys with this one. Okay, compat sub C++. You can download this and then you can use. I also have uploaded the installer for the HANA DB, HWCCT as well as the subcar. So you can use into your environment to test out the installation. Okay, so basically the source ENV profile.sh will call this library compat sub C++, that particular version. Okay, so let's see. Before we run the HWCCT, we source to that particular ENV profile.sh. Okay, so we can check the version of HWCCT that are running here by executing the HWCCT -v. Okay, so we know that here version HWCCT 2 version 37 here. Okay, 237 is the one that are running on the HWCCT. Okay, so we can start running the HWCCT. Usually, okay, before we run, as I mentioned, we must check our JSON file. We will run the landscape and file system long here. Okay, we are not running the short. Okay, so before run or execute the test, we need to edit the host name of the configuration first. So we will vi landscape.json. Okay, make sure here on the landscape there is one part of the host name you need to change here next to the blades. Okay, make sure it is correct as what has been registered for your alpha host name. Okay, same thing goes to the file system long. Okay, there are three parts you need to change your host name on the file system long. The first one, same as the landscape, is next to the blades. Second one is next to the HANA data because it will access the HANA data inside your local disk, here rel02. And then the last one is next to the HANA log. Make sure these three lines or these three configurations, you put the correct host name based on your current host name for that alpha. Okay, so like here is already all the rel02, rel02 and rel02. Okay. Okay, once you confirm, then you can start. Usually I will start the landscape because landscape is a very quick one. It's just a few seconds only. Okay, then I will leave it file system long to run overnight, and then we will see the output, sample output from the rel01. Okay, so here, okay, usually my best practice when I run the HWCCT, doesn't matter landscape or file system long, I will pipe the output into a directory. Into a text file, and then I will give a name and then put a .txt. Why I do like that? Because later when I do one, I want to do a presentation to customer or I want to do a documentation, I always can copy or FTP out the txt file and then open using my Windows laptop. So that's the reason why I do like that. Okay, so that's what will be done today or here. So cos env profile sh dot slash hwcct hyphen f. Okay, then we will execute the landscape JSON, and then I put the output to the HANA chat. Okay, then in result rel02 underscore landscape dot txt. Okay, so what does the syntax do here? I will execute the HWCCT. The test is landscape test, and then I will pipe the output of this test into this file, HANA chat HWCCT result, and then I will save it into the rel02 underscore landscape.txt. Okay. Again, because this txt file, I can FTP or SCP to my Windows PC, I can use it and open it for my presentation and documentation. So if like that, right? Okay. So if I do set right. So if I can view this file because it has been output to this folder and file, if I see here, okay, should see the same version of HWCCT 237, okay, and then it will run, oh sorry, it runs on the correct host name, the blade. Where is the blade name? Here, rel02, and then the output table is for rel02, okay. So it's quite fast, just 3 seconds. That's why I said I don't see any test or landscape up to 5 minutes, but that's the benchmark from SAP. It estimate maximum maybe up to the 5 minutes, maybe on the old server before. So what it does, what it validates. So first thing first, it validates the OS here. So Our OS here is supported for or certified for Red Hat for HANA together with the distribution. Okay, Red Hat is certified and then the distro is the RHEL 8.2, 8.1 here. So it, so it's certified to run SAP HANA DB and then validate the clock source and the CPU. This one is the relate to the CPU and then CPU is not the how many core. It here validate CPU is your power is our power CPU, power PC, PPC. So it validate the PPC success. It can be run with the HANA DB. And then hypervisor, if you are running on the Power 8 and Power 9, no need to worry the hypervisor. Our hypervisor on Power 8, Power 9 is certified to run the HANA DB. Okay. Now it validate the processor. Here this one that I mentioned on the first day, yesterday on the unit number 1, we have a few technologies under processor visualization. Here it recommends to use dedicated. As I mentioned before, when you see the word dedicated, means it is a physical processor, means 1 core, 2 core, 3 core. It's not a shared. Okay? Or you can run with a dedicated donating. What does it mean, a dedicated donating? For example, you assign 10 core, but during a certain time, the alpha only use 4 core. So the remaining 6 core can be donated to others alpha. So that's what the means of dedicated donating. Okay, but we don't see any shared processor here. No need to worry because shared processor, as I mentioned, is certified to run for HANA DB on production and DR. So no need to worry. It's just a warning here. It's not a fail. Okay. Next, it will validate the Linux kernel version. Since you already update by right, if you run the 8.1, quite latest, should be success. Okay. Runtime and memory and also the memory distribution. Okay. The network also will be validated and then how the memory ratio, core to memory ratio. Okay. By right, power will use the TDI5, so no need to worry. And then the last part, it will update, it will scan your disk, okay, file system config. Okay, because it will validate recommendation from the SAP to use the XFS. That's why the reason when we create LVM, I create the mkfs.xfs because this one will be part of the validation as well. Alright, so that's the things will be validated by using a landscape output. Okay. So if we want to run the file system long, okay, you just double confirm file system long. Okay, all the blades, HANA data host name, HANA log host name has been changed. The host name to our respective alpha here, RHEL02. Okay, so I don't think there's no problem to run the HWCCT. But here we will let it run. So we will continue with the sample on the RHEL01 after this, right? So same thing, same steps, even same command HWCCT-F. The only thing different is you select the different JSON file in file system. Then again, my preference, I always pipe into the readable file. Okay, so here the syntax almost the same as what I did for the landscape. I run the HWCCT for test file system long config the test, and then I pipe the output to the readable file called inside the directory HANA share HWCCT result. The file name called RHEL02 file system long.txt. So later this txt file I can extract to for documentation and presentation, right? Okay, so here it will take a few time. What I want to show is HWCCT results rel 02. Okay. Oh. So here, this is the benchmark rel 02 HANA data. Okay. So same thing, rel 02. Okay, this is the benchmark from the SAP. You see, very long time, 6 hours plus. So it will take a few times. On my experience, it could take about 3 to 4 hours to be finished. So we cannot see the complete output here. We will use the rel 01 that we ran before. Okay, so this is the sample. If you see, the actual output for the file system long test is not as short as the landscape test. Okay, it will be quite a long output. Okay, but here they are separated into two parts. The bottom one is for your log, the output for log. Okay, your log volume, HANA log. If you scroll a bit up, okay, it will be another table for your here HANA data. Okay, so there are two parts for the output for data in the bottom, in the upper part, and the bottom part will be for the HANA log. Here, I already include the KPI, so for us easy to analyze. Okay, so this is by using the SanDisk. We see the output here is quite big compared to the KPI here. But please bear in mind, as I mentioned during the slide this afternoon, even though you see the number here is very low, don't be too confident, because if you really don't fulfill or follow the guideline from SAP, there's still possibility for you to get lower than this number, especially if you are running with a internal disk, not a SanDisk, plus the internal disk is using a Viscasi and it is a very low RPM spinning disk. Then there will be a possibility you can get lower than this number. Okay, here we are using a SanDisk, but I'm not sure whether it is a SSD or spinning disk. But here the KPI should be past the benchmark. Okay, latency for data there is none, but as long as you need to monitor, if there is no bottleneck or performance issue, then it should be fine. Okay, the most important part here on the data volume, you need to make sure the initial write, overwrite, and read, the output or the value that you get here should be larger compared to the KPI. Okay, different with the log down here. Log, it has the latency. Okay, only for the 16K block size and also for the 4K block size. Okay, make sure it does not more than 1000. Okay, 1 meg is quite big, so there is no benchmark here. Same thing as the data, you must make sure the output that you get, initial write, overwrite, and read should be larger compared to the output KPI here. Okay, so that's the first thing you can verify for the benchmark. Okay, second thing, you also can verify, because here we have a lot of numbers. Okay, so make sure the numbers here for every test that been tested here, the ratio trigger time, because there are a lot of testing being done, and then every test has their own ratio trigger time here. Make sure your ratio trigger time from the output is not more than 0.1. Okay, if you see, scroll up here, 0.02, this one also ratio time 0.02 for 1A. Okay, if you go up 0.001, okay, up to the first line, you will see a lot. Okay, a lot of ratio trigger time here, 0.045. Okay, make sure this is another way you can validate the health check for your disk. Okay, depends on HANA data or HANA log. Okay, 0.2206 and etc. Okay, 0.0041, 0.0041. So this is the two methods that you can use. Other than compare the KPI table, you also can check the ratio trigger time to the IO time for each test from this output. Okay, so there are two ways to check your this performance from the HANA database perspective. Okay, right. So I think that's it for the demo 5. Any question? Right. So far there is none. Okay, Mr. Sorry, I forgot to say, Mr. Sakana, thank you very much for your feedback and question just now before we go for the break. Right. So without any further waiting, I will continue with the next agenda. Unit number 7, the last one for today. Where is it? Sorry. Alright. This one. Unit number 7. Okay. Sub HANA HA solution and the HSR deep dive. Okay. So I think we are not having break now because we just have a break less than 1 hour before. During the unit 7, I will do a coffee break during the unit 7 so that we can have a bio break and etc. Okay, we'll proceed with the unit number 7, Sub HANA HA solution and HSR. Okay, so first thing first, before we go to any HSR or high availability cluster whatsoever, Red Hat cluster or SUSE cluster, what is actually high availability? Okay, we need to know the basic concept high availability. Why does the high availability is needed? What it can give benefit to us or maybe to the company. Okay, so basically here, the the key point is I already highlighted on the red color. High availability, the main purpose is to eliminating the SPOF. What is SPOF? SPOF, single point of failure. If we yesterday we went to the unit number 3, right? Even the SEA, the shared Ethernet adapter, have the SEA failover. VIOS has the VIOS failover. Even your disk also multipath. So all those kind of technology try to eliminate single point of failure. Not only the HSR or maybe Red Hat or SUSE cluster, even our infrastructure also has their own way to avoid or to eliminate the single point of failure. So that's the purpose of high availability. Okay, so avoiding single point of failure is number 1. Okay, there is another purpose of high availability. It also need to provide rapidly resume operation after system outage. Okay, so let's say you have a power outage or maybe you have a system failure. How long you can recover your system into the secondary? Okay, that's also been part of the high availability description. Okay, so with these two function, it will give the business continuity. Okay, the business continuity for customer is number 1 because for some critical customer like banking, government, manufacturing, most of the customer, they for them they may not able to afford any downtime. So their business continuity here is number one. So that is the reason why high availability is required and proposed on their environment. Okay, so the goal of high availability is to keep services as available as possible. Okay, this one basically tie back to the business continuity. Okay, so that's the what is HA or high availability. In power, we also have a power HA. So many. We have the VM recovery, GDR. Depends on what the situation, on what of the environment needed by customer. Same thing goes to the HANA, goes to the SAP HANA. Okay? SAP HANA is also designed for high availability. We have the HSR, HANA System Replication, natively supported by SAP HANA DB. You no need to configure or purchase any additional license for that. Byra is already designed and available for you guys. Okay, for all of us that using the SAP HANA DB lah. Okay, so it recovers major ranging from fault, software errors to disaster decommission. What does it mean by here? So it can support both your HA in the same data center up to disaster decommissions, mean this is up to your GR. Okay, so it can be supported the HA for the same DC up to the different DC, which is your DR. Okay. However, HSR is a manual takeover. If you want to do takeover or failover, you need to manual takeover and then you need to register back. Okay. HSR is like that. The behavior is like that. So how to automate? Okay. So we will work with our add-on. Okay. They call it, if we are working, we are installing on the Red Hat, then we have the Red Hat HA. If you are using like last year's, the session on last year, we are using the HA for SUSE cluster. So SUSE cluster is the add-on here, okay, that complement your HSR to have more reliability, scalability, and availability. So all the liti here, in other words, we can summarize as the automation, okay? Because with, as I repeat, as I mentioned just now, HSR is fully manual task. You need everything's manual. So with the add-on of Red Hat HA or SUSE HA, it will help to automate all those manual things. Okay, so that's the introduction of the HA. So why we need for HA for HANA? Okay, it will be the same reason what we mentioned on the previous slide. Okay, downtime. If best as possible, we try to avoid any downtime happen. Doesn't matter to our DB or maybe up to the infrastructure level. Okay, for some customer, they can avoid their machine to down, but they cannot avoid their DB to down. So they just have the HA on the DB level, but they can leave their machine to down and then do maintenance because their database already pointed to the backup or maybe to the secondary server. Okay, so it depends on their demand and as well as how they can afford the downtime. Okay, so downtime can be a lot of costs. Okay, a lot of factors can cause the downtime. So see, this is just an example. It can be from your equipment malfunction, maybe your hardware or maybe your power supply does not function, or maybe your software network failure, someone kick off the cable, accidentally unplug the cable, or maybe software bugs, something, or major disaster like your geo, maybe your, what we call it, earthquake, fire, flood, and etc. Okay, the most important thing here that I would like to highlight in the green yellow is the human error. This is the, even though you buy 1 billion USD machine with a very high function, very technologies machine, but human errors is something very hard for us to avoid. Okay, even though the machine is the high-end machine, but when there are some, because we are normal human being, we cannot afford to avoid any mistake. Sometimes could be silly mistake, sometimes we are unforeseen mistake. So human errors here is one of the factor. It was happened on one of the bank customer here. where they are trying to do a DR activity and then suddenly something happen, their engineer cannot recover the machine and then they decide to restore the data, and then with the human errors, the wrong data has been restored. So the human errors plays a big factors there. Okay, so that's the reason why we need the HA, not only for our infra but also for HANA. Okay, so does the backup is the only solution against system loss? It's not only the backup. Okay, backup usually will be the last line of defense here. Okay, if your HSR, if your cluster doesn't work, okay, backup could be the last line of defense. But we need to understand the backup will require more RTO, okay, recovery time objective, and also higher recovery point of objective, okay? Because backup is not something like your warm standby, okay? It is a cold standby. You need to do a lot of things, okay? You need to find your backup. Sometimes your tape could be on the different side. You need to collect it and then you need to restore. Restore will take a few times, maybe a few hours, up to 1 or 2 days, depends on how big is your system or maybe your database. So backup, yes, it can help, but it will be the last option. Okay? If you are doing on the DEV, QA or non-production machines, then it's fine. Because that kind of situation could have uh, could be down for a few times or maybe a few hours or a few days, okay, as long as it's not production. But what happens if there's a production machine? Okay, so backup always be the last line of defense. Okay, the first line of defense will be our HA. Okay, because HA could be considered as a warm PR or warm backup. Okay, anytime your machine or your DB, your LPA still continue to be working as normal. Okay, there is no downtime will be required, and etc. Okay, so HA and DR covers a few tiers. Okay, I would say a few tiers. Okay, it could be from the same data center here, campus cluster, or maybe just the next few meters of data center, or it could be from a metro cluster less than 200 kilometers, maybe on the same state but different location, okay? Or maybe totally different geo, maybe more than 300 or 200 kilometers away between the data center. Okay, so there are a few tiers of HA and DR that can be implemented on customers as well as our SAP HANA environment nowadays. Okay, so depends on what kind or what the architecture of backup they want to implement. Okay, here the down tree here, number one is host auto failover. Okay, host auto failover is dedicatedly used for your scale out, where you have a few nodes for the HANA DB. But for us, for power system, we are using scale up, UP, okay, not out, scale up. Okay, so please don't get confused as what myself and Mas Aldi mentioned. Power system also have terminology scale out and scale up. Again, on the power perspective, scale out and scale up refers to their offering the machines. Scale out is the entry level and mid range. Scale up is the enterprise machine. Don't get confused with the scale out and scale up terminology used by the SAP HANA. So because scale out and scale up on the SAP HANA terminology is for their architecture, how they deploy the database. Okay, so here, post auto failover is for scale out. You have a specific amount of nodes for the active nodes and specific amount of nodes for the standby node. In case one of the node is inside your active node down, then you can use your standby node. Okay, so that's for the scale out. Okay, but for us scale up here, number two, we have option system replication, the HSR, HANA system replication. Okay, the HANA system replication can cover for two. Okay, for both HA as well as DR. HA means they are on the same data center. Okay, that we can use a few replication mode. DR also can be supported where they are on different data center, maybe a few kilometers apart. We that using different replication mode. So the replication mode for HA and DR we will go through after the next few slides. No need to worry. Okay. Alright. So this is on the HANA level. Okay. You will have almost like n plus n here between the node number 1 and node number 2. And then the replication happens on the node level or maybe on the HANA and OS level. It does not happen on the storage. Okay, that's the HSR. Last, the option number 3, we have a storage replication. Because here, that's why the recommendation from SAP to use the external storage. So you can fully utilize whatever features and function on the external storage you can use, including the storage replication. Okay, let's say if your storage replication can support a few kilometers DR, then you can utilize that storage features, and then the DR will happen on the storage level. So we on the HANA level, we no need to worry. In case if one of the storage on the primary side down, it can be replicated to the second storage. Okay, so that's some of the features available for SAP HANA implementation for the HA solution. Okay, alright. So SAP HANA, this one is scale up HSR. As what I mentioned here, we need to have like what n plus n, right? So HSR is a contingency solution used to duplicate the HANA DB. Okay, so in other words, it uses a different system. Okay, it is not logic. If you put your HA on the same machine, then for what purpose it will be the single point of failure? If in the same machine, then your machine, let's say this one in the same machine, right? S924. What happens if this machine is down? Means your primary and secondary here also down. Okay, so that's what we mentioned here. It means that should be on different system. Okay, different system means they will have their own independent storage. They will have their own independent OS, as well as the processor and memory as well. All the resources are independent between the primary and secondary. They are not sharing the same. Okay, unless they are sharing the virtual IP, that one is different side, because that one is already covered more on the OS cluster. Okay, so by right, the resources between primary and secondary should be independent. Okay, so here we will see some of the replication mode. Okay, replication mode is used by the HSR. We will go to that after this, maybe one by one. Okay, so this one has been mentioned by Mas Adi on the chapter number 5 this morning. Okay, we have two options. Okay, for the HSR and DR, we have two options here. Okay, here we will start with the performance optimized option. Okay, on the left diagram here, inside here is your HSR. Okay, where your secondary server here has a data preload here. Okay, they call as a data preload. When there is a data preload active or enabled on your secondary, then we know that this solution is a performance optimized option, where the secondary is a warm standby as mentioned here. So your secondary must have the same resources as what has been configured on the primary. That's what we mentioned, 1-to-1 node size. Okay, if your primary has the 128 gig of memory, then your secondary also must has the 120 gig of memory as well. So it must be 1-to-1 mapping for a performance optimized option. Okay, so the full diagram here, the green color box, because it's already integrated with the Red Hat or maybe your SUSE cluster. So that's why it's pointing to the virtual IP, because virtual IP is used by your OS cluster. Okay, it does not direct to your maybe IP for number 1 or IP number 2. It points to the virtual IP. Okay, so what does benefit that we can get from the performance optimized? Okay, performance optimized is usually the best solution to have a rapid or faster takeover. Okay, because here resource are used for data preload on secondary. Okay, because this is the main key thing that makes the takeover faster compared to the other options. there will be always pro and cons. But here, in terms of costing, you need to sacrifice your secondary. It's just a standby. All the resources will be on idle. Okay, so it is kind of wasting. But in terms of performance, yes, number one. But in terms of costing, it's not so good on that area. Okay, so if your customer have a limitation on their cost, so this solution could not be a benefit for them. So they will. So this is what I mentioned here. Okay, using the Red Hat cluster, okay, as the add-on. Okay, so for those who customer that has limitation on their cost or budget, they can choose the second option. But as I mentioned, every option will have their own advantage and disadvantage. The advantage of this solution, the cost optimized option, they will have the option to run the non-production instance inside their secondary. Means there is no data preload here. Okay, means maybe primary here 128 gig, but here maybe just 64 gig. So what happened to other 64 gig? It's been used by the non-production LPA or non-production environment. So what happened if DR or maybe takeover need to be done? Okay, so it will take a longer time. Okay, because you need to preload all the data into the memory first. By then check one by one. By then after everything's okay, then only the takeover can happen. Okay, so that's the advantage. Okay, so there are give and take on that. Here it is considered as a cold standby. Okay, so cold standby, the RTO will be longer compared to the warm standby. Okay, so these are the two scenarios supported on SAP HANA system replication. Okay,
Nấu cơm rồi đúng
most
không?
of
Đâu
the
là
customer, based on our experience, they will focus on this one because their system availability is number one. So they are not afford to have a downtime for too long. So they are using this option. But I don't say that no customer use this option. Yes, there are a few customers implemented with these options. Okay, but they already aware about the risk and disadvantage of this solution. There are also advantage. I don't say there are zero advantage here. Yes, there are some advantage where you can run your non-production. You can save the cost and budget. Alright? So, SAP HANA scale up with HA cluster pacemaker. Okay, what do you require? Okay, you need to have at least 2 node cluster only. Not at least 2 node cluster only. If you have HSR without the HA cluster, yes, you can have a multi-tier, multi-target or whatsoever. You can even have a DR, okay, on different side. But with a Linux HA cluster pacemaker, there are limitation there where it can support 2 nodes cluster only. Okay, so SAP HANA scale up. Okay, single alpha. This one basically almost the same things. Okay, single box to a single box replication only. Basically, they are explaining the same thing. Okay. Next, number 3, as what I mentioned during my installation of SAP HANA DB just now on the demo, the previous demo.
Bây giờ đang
counterpart, your node number 1, node number 2 must have the same SID and instance number. Okay, this is a must. This is rules of thumb.
Hình như cái phần mềm đó là con nốt là nó không có hàng vật lý đúng không ta? Con nốt không?
Later tomorrow before.
Đúng rồi, không có hàng vật lý.
The HANA cluster here, SID will configure the crony. Okay? NTP available on the previous, maybe SUSE on the previous SUSE 12. Start from the 15, they are using crony. Same thing goes for the Red Hat 8.1 and Red Hat 8.2, we start using crony. Basically, it's the same concept to make sure both nodes or any nodes on your cluster having the same time synchronization.
Cái phần mềm Power VM hả?
You must configure if you want to integrate with the HSPR cluster. If you just want to create the HSR,
ví dụ ghép vào phần mềm khác hả? Rồi tách sau hả?
It's just optional. But once you want to go with the HA cluster pacemaker, then it is a must. Okay, the cluster must be installed on the same data center.
Ấy thì anh thấy Thành ghi là thấy Kinh Ninh ghi đúng rồi nè, là và hai bên bao VM Enterprise V3 được nè, ghép với ASD được đó, ghép với AS hợp lý hơn, còn cái la bao VC kính không có.
That is an option. Okay, if you want, let's say this one is
thực ra ghép vô một trong hai cái này đều giống nhau cả, mà nó là một phần ảo hóa của hai thằng này hết, đều quản lý được hết, một trong hai đều được hết, không sao đâu.
This one is let's say one location. Let's say it is a 10 km. If you still want to use the HA cluster, you must
make sure
site number 1 and site
number
2 is on the scratch cluster.
Để quan
If they are both on the scratch cluster where their network is on the same segment, then the HA cluster can be done, can be implemented there. Okay, that's the only prereq. If they are already first thing first, different data center with few kilometers apart, and then their network segment is different, and then they are not on the same stretch cluster, then your HA cluster pacemaker, doesn't matter Red Hat or SUSE, cannot be implemented there. Okay, if your data center different apart but on the same stretch cluster, then it is possible. Okay, you must make sure on that. Okay. So,
sorry, I just want to add additional comment. So for the time sync, in the project, I think in the real project, even for production, we need to set up like one centralized time server for application as well as database. So in case if there is a problem or something like we need to find out the root cause, the timeline, the timestamp would be synced on each application and database. That's just my suggestion. So I think, in production, make sure in the customer they have the centralized time server like NTP server. If they don't have the NTP server, then we build just one centralized for in one system like SAP HANA with the S4 HANA in one environment use similar centralized time NTP like we have did in the project in the production environment. That's just
Thank you, Mas Aldi. Okay, but yes, thank you, Mas. So it is best to have their dedicated NTP server. But in case maybe for testing, that actually there was last year one session that we use our own laptop Windows. There are a few ways you can do. You can Google how to make your Windows 10 or maybe Windows Server as a NTP. Then you can use it as the NTP server. But NTP server, please make sure it is a what we call it, a consistent server where you no need to shut down, you need to bring it back. If you use your laptop, then you need to leave your laptop as long as the server use the NTP. So yes, recommendation, if you can provide a specific or dedicated NTP server, that will be better lah. Okay, but there is a few options as a temporary or maybe walk away alternative way solution. Next, this is a logical diagram for how the HSR and SUSE or Red Hat cluster set up on the same data center. Okay, so here, on the blue color part here, we have our DB LPAS. Red Hat cluster also can work together with the application, but the one that we did before is with the SUSE cluster, we integrate with the ASCS and ERS. Other than the ASCS and ERS, maybe it can, but we don't have any chance to implement the cluster to be works with others application. Okay, but here for HANA database, it is 100% sure that the OS cluster, doesn't matter Red Hat or SUSE, can work together. Okay, that's why on the logical diagram here, you can see LPA number 3 and LPA number 4 here, they have in between HANA system replication. plus the cluster takeover. The cluster takeover is the OS cluster because it used the virtual IP here, right? So here, if you see here, because this one is the primary, because later when we do our demo, the replication mode here, this is the replication mode available. Okay, the replication mode is configured on the second node when you want to register into the HSR. That's the reason why it is putting here. Okay, it's not been, the yellow box is not on the first node, on the primary. Okay, because you set the replication mode when you want to register the secondary into the HSR. Okay, so in this diagram, it just to show you that yes, the HANA DB can work with the ASCS and ERS, and then the Red Hat cluster and the SUSE cluster also can manage both ASCS and ERS on this diagram, as what we mentioned on this diagram. Okay, so here they have their own data and logs, as what been mentioned on the last few slides. Okay, they have their own resources, they have their own OS, they have their own system. Okay, next, how does the logical diagram looks on the DR sites? Okay, as I mentioned, SUSE cluster or Red Hat cluster only can cover on the same data center. Okay, if we go to the same, here the last point, cluster node must be installed on the same data center. So in other ways, if you have a DR, okay, because this is on the same data center, right? So DR will be totally different data center. So that's the reason why the cluster takeover here is only on the DC side. There is no here. Okay? Because this one is already considered DR and already different data center. Okay. For HANA system replication, if you see on the replication mode, okay, for DR there is only one option, which is the asynchronous. Okay, if within the same data center you have three modes, okay, full sync, sync, and sync in mem. But for DR options, okay, you can use only one option, which is the async. Okay. However, if they are all on the stretch cluster again, I keep saying about the stretch cluster because on some customer, even though they are on different data center, but their environments of these two data center on the stretch cluster, and they're having the same network segment. Okay, so that one is possible. Okay, so here we are seeing the tiering. Okay, this one is considered as a multi-tier. Later we will go through on the next few slides about the multi-tier and also multi-target. Okay, no need to worry about that because on the HSR, that's a possible. We have a few tier, tier 1, tier 2, tier 3, and so on. Right? So in this slide, it shows the logical diagram. How does the DR set up? Okay, just now you have a DC, now you have a DR. Okay, there is a possibility. Let's say customer just purchase two machines. One is for DC and another one is for DR. So they don't afford to have a secondary site or maybe a second machine inside the same DC. Okay, so what they can do or what we can propose is we have a DR, but it depends on the replication mode. Okay, if your cluster is on the search cluster, then you can use either sync or sync mem or sync full sync. Okay, if they are on different cluster or different subnet, then the only option is async. Okay, if you see here, the cluster support for between the apps and also for the DB on the OS part cannot be supported because this one is already considered a different data center. Okay, so there are three scenarios here for the logical diagram on how we can implement the HANA database with DR or without DR together with the HANA or together with the applications. Okay, ASCS, ERS, and etc. Okay, all right. So I think next few slides we will go for break. Before that, we go to the SAP HANA overview. Even though SAP HANA is a in-memory database, but it still have a persistent storage. Okay? Persistent storage is your physical disk. Okay? Even though it is in-memory, but it still need to flush all the data from the memory into the volume, persistent volume, which is your storage. Doesn't matter SSD, NPIV, or maybe spinning disk. Okay? So in-memory primary data, there are a few user data, metadata, all those things here. Okay. Okay. So the redo log contain change data. It will save to the disk when transaction commit. Okay. So the redo log, when the transaction commits, then it will be saved into the persistent. So every time it commits, it will be saved to your persistent volume, log volume. That's the reason why we still need to get a log volume exist or assigned for your HANA database. Okay. Save point here, change data and undo logs are written for every 5 minutes. Okay. So save point will be saved into your data volume. Okay. So every 5 minutes of interval, the default one, it will be saved, persistent, or maybe flash. The will be flashed to your persistent storage, to your disk. Okay. So the system replication again, this is almost the same slide with what been presented before. Okay. So what happened behind? Every time the system HSR is enabled, what happened in the background? Okay. The first thing, every server process on the node secondary establish a connection with counterpart. Okay. So here, if you have a name server here, so here also with name server, it will sync with the counterpart. If you have ABC service here, it will sync with their counterpart on the primary. Okay. So what been mentioned here? Okay. On the first time HSR is deployed or established, it will request a snapshot of the data. Okay. So and then depends on the operation mode, there will be like a delta, data shipping, and etc. Okay. But the first time the HSR is deployed, the secondary will request a snapshot of the data from the primary. Okay. So that's the first thing. Second thing, what happened here? All log changes on the primary system are constantly replicated. So every log changes will be constantly replicated to the secondary. And then every persistent log in the primary will be sent. Okay. So same thing, you will be replicate the log and send to the secondary. Okay. The transaction in the primary system is not committed before the logs are replicated. Okay. Then we will go through the replication mode, then we'll see on what criteria the logs replicated consider success here. Okay, because it will be depends on the replication mode that you choose for the HSR. For some situation, the logs already consider committed once it reach the memory. On some replication mode, it is considered committed after it has been flushed to the persistent volume. So it depends on the replication mode as well. That's why it's been mentioned here. Okay. So that's in general, high level, what happened in the background once the HSR is set up. Okay. Okay. Right. So that's it. Before we go, because just now I said about the replication mode, because it determines how your log consider committed, write return successful. So before we go to that, we will take a break, maybe about 10 minutes break, and then we will continue.